Good morning, everyone. Waste elimination is a cornerstone of lean manufacturing. Smart manufacturing technologies provide innovative tools to identify and address waste efficiently. By leveraging advanced technologies such as IoT, AI, and machine learning, manufacturers can optimize operations, reduce costs, and enhance productivity. This presentation explores how smart manufacturing tackles the 7 key types of waste identified in lean principles. The solutions presented here are not meant to be an exhaustive list, but rather a selection of possibilities to illustrate what is possible. To tackle transportation waste, smart manufacturing leverages real time tracking systems, automated route optimization, and advanced analytical tools to efficiencies. Some of the solutions start with tracking. RFID and GPS material tracking systems can monitor material movement in real time, pinpointing inefficiencies and delays. Connected forklifts, AGVs, and AMRs are equipped with sensors that can track the movement of materials and delivery times. And then over time, this information being collected can be used by the systems that follow here. We have optimization and management solutions, such as automated logistics route analytical systems can map and analyze material flows, recommending layout adjustments or alternate to minimize transit times and material handling. Warehouse management systems can streamline storage and retrieval options, reducing unnecessary material movement and handling errors. And then we have analytical tools such as motion study algorithms. And by analyzing historical movement data, manufacturers can identify patterns of inefficiencies, such as repeated back and forth transportation between stations and other duplicate movements. Simulation software for layout optimization, digital twin, virtual testing of layout changes, ensuring the most efficient setup before physical modifications are implemented. And then AI-powered logistics. Advanced algorithms continuously optimize transportation plans, accounting for production schedules and real-time shop floor conditions. For inventory, smart manufacturing employs AI-driven forecasting, real-time monitoring, and just-in-time principles to address inventory waste effectively. This can be done through demand forecasting with machine learning. Predictive models account for factors like seasonality and market trends, ensuring inventory levels match anticipated needs. Real-time stock level monitoring. IoT systems can use RFID tags and barcode scanners to track inventory in real time, providing actionable insights and triggering alerts when stock reaches critical levels. AI-driven inventory optimization. These platforms analyze demand patterns and historical data to forecast material needs, automating the stock replenishment process and reducing surplus. And then also reduction strategies. Just-in-time inventory models help to align procurement schedules with production needs to minimize on-hand inventory. Predictive supply chain analytics provide advanced tools to dynamically balance the supply and demand to avoid overstock situations. And automated vendor management integration. Real-time integration with supplier systems ensures that seamless replenishment based on current production schedules happens very well. For motion waste, using wearable sensors, augmented reality, and robotics, utilizing wearable sensors, augmented reality, and robotics, you don't wear many robots. Smart manufacturing optimizes workflows and minimizes unnecessary motion. So things like ergonomic analysis tools, you can have motion tracking sensors such as advanced gloves. Wearable devices and motion tracking systems monitor those worker movements to identify inefficient patterns such as excessive reaching or bending. You can create heat maps of worker movements using visual tools that highlight high traffic zones and inefficient workflows, enabling data-driven layout adjustments. Video analytics, these solutions can automatically identify when workers are not following the recommended motions. And this can then be used for training to reinforce proper techniques. You can implement continuous time studies with these solutions as well. And so the inputs from those technologies can be combined as inputs into that continuous time study that continuously looks to optimize work procedures and workstation design. There are also optimization technologies such as augmented reality workplace design. So AR platforms can simulate the workstation layouts, ensuring that tools and materials are optimally positioned. Robotic process automation. So robots and cobots handle the repetitive tasks like material handling or assembly and reducing the manual motion and associated risks. There's workflow modeling tools that use 3D biomechanical modeling and detailed models analyze the workflows to propose ergonomic and efficiency improvements. And then you have AI powered ergonomic suggestions where these AI systems can recommend workstation modifications such as height adjustments or placement changes to enhance worker comfort and efficiency. Weighting is another thing that can be addressed by smart manufacturing through predictive maintenance to address downtime and waiting for machines to get repaired, and real-time monitoring. Smart manufacturing minimizes those downtimes and ensures balanced workflows to reduce when you're waiting for materials. So, from a monitoring technology point of view, IoT sensors and machine monitoring systems can measure that equipment downtime, tracking the causes, highlighting underperforming assets, and helping to ensure that the bottleneck assets stay running on a continuous basis. And then video analytics can perform a similar function for manual operations, where they can monitor those manual operations to identify when workers are waiting and to help identify the root causes. So if you have a line that's not balanced correctly and you have a lot of operators waiting for one operator to finish their task before work can move on, that can be identified and addressed using those solutions. Also with optimization strategies, so you can have dynamic scheduling tools that make real-time adjustments to production schedules that optimize that resource allocation and ensure smooth workflows. You can have machine learning for bottleneck analysis so that the algorithms can identify and address those recurring delays in the production process. And you can have not only can you do predictive maintenance, but you can also schedule those tasks so that they can be done when they're not going to cause delays in the work process itself. For overproduction, which is when you're producing more than is needed or before it's actually needed, this is readily addressable through real-time production monitoring and demand-driven strategies, but it has to be paired with attention from management so that when people are overproducing to that schedule, you can get the visibility, but you still have to get them to stop and only build what's needed. So if you look at IoT sensors and analytics, you can look at real-time production monitoring again so that you can track production output against demand and flagging instances of overproduction immediately. You can provide automated alerts to notify operators when production exceeds the planned requirements and enable rapid intervention. But let's also not ignore just enhancing some of the things that Lean has to address this. So with pull-based production, you can digitize the Kanban systems, which has advantages on its own, but you can ensure that production aligns with the actual demand, minimizing surplus, just-in-time production, making sure that you only build to what you have from an actual demand signal. And there's, again, ways that you can help digitize that to make that more efficient. But then you can also look at things like predictive forecasting, where if you're in a make-to-stock environment, how can you get that demand forecast to have a minimal error against actual demand. And the closer you can get the forecast to the actual demand, the closer you can keep production to that true demand signal. Uh, from an over processing point of view, smart manufacturing employs process analysis tools and standardized workflows to eliminate some of those unnecessary processing steps. So, from a process analysis point of view, you can look at things like digital twin simulations, where virtual models simulate and optimize the workflows, identifying some of those non value add steps. You can automate the work analysis with data driven tools that pinpoint inefficiencies and suggest streamlined processes. And there's even comparative benchmarking tools that analyze some processes against industry standards to highlight improvement opportunities. Um, from a standardization approach, um, you can provide that standardized process documentation with digital work instructions and utilize some of those tools that we looked at earlier to ensure consistency and ensure that people are actually following the standard work instructions, such as the video analytics that help ensure the compliance with standard procedures for manual operations. And then you can also implement things like closed loop controls, where the platforms themselves kind of automatically change those machine settings to ensure they're always being operated according to the standards. And finally, defect waste. Um, there's a plethora of different solutions that combine advanced detection technologies with preventive measures to minimize defects. From a detection technology point of view, you have things like machine vision systems with high resolution cameras that analyze products in real time to detect those defects. You have IoT enabled quality sensors, embedded sensors, monitor those critical parameters during production, flagging anomalies such as excess vibration or high temperatures. There's things like thermal imaging with infrared sensors that can help uncover hidden defects. There's other advanced inspection technologies with non-destructive testing, such that will help identify those structural flaws. Um, from a quality control technology point of view, there's digital traceability so that you track each product's entire life cycle, linking defects to specific sources like different machines or different operators and so forth. There's real-time SPC, so you can automate some of that to make that more consistent throughout the process. And that will help identify those process anomalies early, reducing some of those defect rates. And then there's preventive strategies, such as the predictive quality analytics, utilizing the information coming from those sensors we talked about earlier. You can have AI forecast potential quality issues by analyzing that real-time data, and then continuous process automation or optimization rather will utilize machine learning to help ensure consistent and optimal production parameters, feeding back into that closed loop control. So that's it for today. By adopting smart manufacturing solutions, companies can systematically identify and eliminate waste across their operations. The integration of IoT, AI, and data analytics not only drives lean transformation, but also enhances productivity, quality, and profitability. Manufacturers who embrace these technologies gain a competitive edge in today's fast evolving market landscape. If you'd like more detail on the program or to discuss it with me directly, please follow up through any of the methods you see on the screen. The QR code will take you to the Visual Decisions website for more info. Thank you very much.